This question was asked in Amazon interview. Let's see if you can solve it. Hi, my name is Mohit Chavda and in today's video we will solve Amazon tagged question number 733 on Leetcode, which is flood fill. If you see the problem statement of the question, it looks to be very complicated. So let's go to the visual representation where I'll explain it to you in a very easy way. Okay, so in the question you are given a 2D array which is named as image. Here you can see we have the input of 2D array and we have made the visual representation of the same in this way. As you know, in a 2D array, in order to go to any cell, you need two indexes. So here the first index is named as SR and the other index is named as SC. So 1 and 1, which means we are at this position in the beginning. You can see this is an integer 2D array. So apart from all this information, you are also given a color, which is also an integer. Basically what you need to do is from the starting position you need to update the current color to the given color. Say for example, here the given color was 2, the current color was 1, so we will modify it from 1 to 2. Okay, and now you have to go to the adjacent positions. So if I draw it here again to explain you in an easy manner, say this is our 2D array. We were given the index 1 and 1. So if I write down the indexes overall for the 2D array, it will be something like this: 0, 1, 2. So 1 and 1, this is the location we were given as the starting location. So we have already modified the color at the beginning location. After this you can move to the adjacent cells. You can either move to the right, left, top or bottom. So these are the four locations when I say adjacent locations or the neighbors. You can't move diagonally. Okay, you can't go this way or this way or this way. You can only go either left or right or top or bottom. So from this cell you can either go up, you can go down, you can go left, you can go right. Okay, so using these directions you have to update the color of each of the cell where the cell's color matches the initial color of the beginning cell. For example, in the beginning the color was 1, correct? So wherever you find out the color 1 via going to the neighbors, you have to update that 1 to the given color, which is 2. So in this example we have already modified the current cell's color from 1 to 2. Then say for example you go to the right side. When you go to the right side, it has color 0, which is not same as the color of the first cell in the beginning. In the beginning color was 1, right? And here the cell's color is 0, so you won't modify it. You will only modify it if the color matches. So after going to right, you will go to the left side. When you go to the left side, you will see the cell's color is 1, which matches the initial color, correct? So what you need to do is modify this color with the given color. So you will make this 2 as well. Now again from here you may go to the right side, but this is already 2, which is the given color, so nothing is required here. From here you can go to the left, but there is nothing on the left to it because the matrix ends here. Now from here you have two options: either you go up. If you go up, you see the cell's color is same as the first cells, so you will again update this to 2. From here again you will go to the right side. You will again modify this from 1 to 2 because the color matches. Again you can go to the right side. Again you will modify it from 1 to 2. You can go down from here, but this is 0, which doesn't match 1, so you won't modify it. And from this cell we had two options: either to go up or to go down. We went up and then the next time we will go down. Again here we will modify 1 to 2. From here you may go to the right side. When you go to the right side, it doesn't match the initial color because this is 0 and the initial color was 1, so you won't modify it. So you can see we would never be able to reach this cell because you can only go to the right, left, top and bottom. When you go to this cell, you return here because you can't modify the color from here, so you can't move ahead from this side, so you won't be able to go from here to here. Similarly, when you reach this cell, this is also 0, which doesn't match the initial value, so from here as well you can't go to this. Hence this cell remains unvisited and you won't be able to modify this 1 to 2. Okay, so finally your output seems something like this. You can see this and this completely matches. 2 2 2 2 2 0 201, correct. We did not modify any of the zeros because they did not match 1, because the initial color which was given to the cell where we begun was 1. Okay, so we did not modify this one, and we were not able to reach this cell, so we did not modify this as well. So the basic funda is, you are given a beginning location, you need to identify the color which is present at the beginning location. For example, here it was 1, and then you are also given a color in the input. So wherever you find 1, you need to replace that to 2. But when I say wherever, you can only visit those cells which are neighbor to the current cell, and neighbor means left, right, top, bottom. Only these 4 directions you can use to traverse to the cells. Okay, I hope you understood the question. In case you have any doubts, I would request you to take paper and pen, draw this 2D matrix on the paper and use the pen to see like where all you can go. For example, in this cell you have 4 options. You can go top, you can go bottom, you can go left, you can go right, and it is not mandatory that you will go to the top first. You can go to any of the direction in any order. You can take top first, then left, then right, then bottom, anything that you want to do. But the only part is you can only take these 4 directions, you can't move diagonally. Alright, now if we talk about the solution part, then in this question we will use recursion. You can see we can move to the 4 directions like I told you. For example, in this case, from here we went to the top and we traversed to other cells which were neighbor to this cell, but we later also came to the bottom because from this cell we could also go to the bottom side. So this is a clear case of recursion, and the pattern is in the 2D arrays you will see a lot of questions where recursion or DFS will be used. Okay, so here also we will apply the recursion solution to solve this. So in recursion we have to take care of the base conditions, right? So first of all, the base condition would be, like for example, we have 2 indexes here, right? So we have to take care that these indexes remain in the range of the index of the 2D matrix only. Say for example, in the question you are given SR equal to, say for example, 100. Okay, whereas the size of your matrix is 3 by 3, correct? So this is not a valid index, right? So you have to take care of that in the base condition of the recursion, because you'll move to the left, right, top, bottom. There might be a case that you move outside the matrix, so you have to return in those cases. Also, another conditions are, say for example, you reach to a cell which does not match to the initial value of the beginning cell. For example, 0 here, and then in the beginning we were at the cell which had value 1. So in that case also you had to simply return. You can't move ahead from this cell, you can't move to the next cell from here. Okay, so you have to return from that case. And in order to avoid going to the same cell multiple times, you can either use a visited array, that is you create a new copy of the array where you maintain which cell has been already been visited. Whichever cell you have already visited, you can mark that as 1. In the beginning the array already has the default values of 0, so 0 means unvisited. Whenever you visit a cell you mark it as 1. So in this way, whenever you reach to a cell, instead of applying condition directly on the image 2D array, you firstly check whether you have already visited this cell or not, so that you don't keep on coming to the same cell again and again. Although this can be used, but this would take extra space, so that would increase your space complexity. In this question we don't actually require a visited array, because you can apply a simple condition if your current cell's color is same as the given color. So for example, if it was already 2 here, okay, so you would directly return. In the question it is nowhere mentioned that if the initial color is same as the given color, you still have to go around the array. So in that case, because it's not given in the question, what we will do, say for example this is already 2 here and the given color is also 2, so here the beginning cell's color matches the given color. So if we won't do anything else, we will simply return here. This will be helpful in other cases as well. For example, you updated this 1 to 2. Okay, so you went to the right side. Now you are at this cell, you will also modify this 1 to 2. Now again, from this cell you have 4 options. You can go to the top, which doesn't make sense because you go outside the array. You can go bottom, you can go to the right, and you can also go to the left. So we came from left and we are again going back to the left. So if we don't apply condition to that cell, it will be a problem because you will be stuck in a loop. But when you apply this condition, like the color check, because this is not 1, this is 2, so you would directly return from here. I'll show you the code where we have applied all these conditions so that it becomes more clear to you. But what I'm trying to make sure to you is that when you're applying recursion, you need to make sure that you apply all the base conditions. You need to make sure that you are returning wherever required and you are not repeating or going to the same cell again and again, because if you are doing that, you will be stuck in a loop and that would give stack overflow. So now let's go to the Leetcode. Here we are back to Leetcode and I have written a solution for it. I'll zoom it a bit so that you can see it very clearly. Okay, we are solving this in Java programming language. In case you want the solution in some other programming language, just add a comment and I'll provide you a solution in the required programming language. So here we are already given a function where you can see we have to return the 2D array. In the parameters, we are already provided an image 2D array which is of integer type, like we saw here. So this was a demonstration of that only. Okay, so apart from the image 2D array, you are given the index of the beginning cell, because in a 2D array you require 2 indexes to reach to any cell. For example, as I told, this would be 0 1 2 and here also it would be 0 1 2. So in order to reach to a particular cell, you require 2 indexes. Okay, so this is SR and this is SC. Okay, these are both provided to you in the parameter, and then you are given a color which needs to be put in the cells which fulfill the condition. Okay, so as I told you, we will use recursion here. So I've created a new method for recursion. I'll show you that method. So this is the method. We have made a private method because we will simply call this from this class only. So this is a private method and its name I've kept as recursion. You can keep it anything. It has a lot of parameters, so I'll show you. I've documented some of the things. So the description of the method, this is to apply the recursion logic. If we talk about the parameters here, first one, the image, it's a given 2D input array which you can see, which was already provided to us in the question. Okay, apart from this, I have renamed this SR and SC to I and J because it makes things easier for me. If you want to keep it same, it's fine. I just made them I and J and those are the indexes of the starting cell. Okay, after that you are given color which is same as which was given to you in the question. So this is the required color which you want to make in the cells which follow the condition. Okay, and then I have put additional parameter which is current color. What does this mean? It is the color of the starting cell which is given to us. For example, in this case we were given this as the starting cell. What was the color? 1. So this is current color. I have maintained it because we will modify it to the given color. So in that case, when you modify, this value would be changed. So I have kept a parameter which will take the value of this cell which I have named as current color. Okay, so you can see here I have passed simply image directly from the given parameters, then SR, then SC, then color. So all these were directly passed from here. Just because current color, I created a new parameter. What I'll do, image SR SC. So this is basically giving the value of the color which is present in the beginning cell. I'm passing that. Okay, and now what we are going to do, because it's recursion, we have to apply the base conditions. That's very much required, as I told you earlier, right? So we have applied the base conditions which I told you, because we are going to the left, right, top, bottom. So in that case you might go outside the matrix. So in that case, what we need to do is apply those conditions. So we have applied those conditions here. If I is smaller than 0 or j is smaller than 0, or I is greater than image dot length, or j is greater equal to the image 0 dot length. okay, because I is representing the row, so that's why you can directly do this. Because j is representing the column, so you have to do image 0 dot length, because it would be simply this is the array image 0, okay. It appears to be a 1D array, because if you simply take this, it's a 1D array. If you take all of these, this is a 2D array. Now if we do image of 0, this is the 1D array, and then you simply do length of this, okay. Length of this would be for the column. So because j is representing the column, so we have to do image 0 dot length. So if we reach to any of these conditions, we will simply return, because it will give you index out of bound exception in the array, okay. So we have already applied a return statement here. Apart from this, there are other base conditions as well. For example, in case the given color matches to what is already present in the beginning cell, then you simply return. For example, I told you if 2 was present here and the color was 2, because this already matches, you will simply return the array. You don't have to go up down to modify other cells, you will simply return this, okay. So we have applied this condition, because in the question it is nowhere mentioned that we need to handle this case, okay. You can talk to your interviewer that do we need to handle this case. Like for example, here it is 2, what you want is 2 as well. In that case also, if you want to go to the left, right, top, bottom, then of course you don't do this way. But because in this question it wasn't mentioned, this is easy problem, you can directly apply this situation and return from here, okay. Apart from that, we also need to apply one more condition, because we are not using a visited array. What we are doing, if to any cell wherever we go, if it's not equal to the current color. What is current color? The color which was present at the first cell where we started, okay. If that does not match, you simply return. Where is this useful? I show you. Say for example, I told you this example, when we update this from 1 to 2, you go to the right side. From here you can come back to the left side, because it's a recursion, correct. You will come back, but you don't have to restart from here, because you will be stuck in a loop. Here you see the value is 2, which does not match to the initial value, you will simply return, okay. So in this way, this will help you to getting stuck in the loop. So I have also written in top of it, in order to avoid to going to the same cell again and again, we will apply this condition. And using this, we don't need a visited array, okay. If you use a visited array, it would take extra space. If we do this, it doesn't require extra space, okay. So after this, what you need to do is simply modify the color, because now you are sure that the cell where you are present, it has the current color, okay. So you modify that to the given color, okay. So you make this statement, and after this we need to make recursive calls. I told you 4 directions. This order doesn't matter, you can make anything on top, anything on bottom, but I just made bottom like I plus 1j, because I represent the row. When you do I plus 1, it's to the next row, so you're going bottom. When you do I minus 1, basically, so here it was I equal to 1. Say for example, we take j equal to 2, okay, this was a cell. When you do I minus 1, so you are to this row and this column, so basically you have gone to the top, right. So same thing I have written here, top. Other condition would be, you keep I same, you just increase the j, okay. When you're doing j plus 1, you are basically moving to the next column, so you're going to the right side, okay. I've written right. And when you do j minus 1, you are basically going to the left column, so you are doing left, okay. So these are the 4 recursive calls. As I said, order may change, you can write top at the top, bottom at the bottom, whatever you want to do, it's fine, but you have to apply all these 4 conditions, okay. So based on this, the recursion will happen and you will get your modified image, and we'll simply return that. I'll zoom it out so that you can see the complete solution in one go, so that it's easier for you. You can see we have applied a recursion method, although I think this is very small piece of code. I've just added documentation, so it may look big to you. So we simply call this method and return the our 2D array. So maybe this is a function you want to focus on, so I'll zoom it again a bit so that you can only see this recursion function, okay. So there you go, this is the method which was of prime focus. Now let's try to run the basic test cases. Let's see if everything is working. So the basic test cases are working. Let's try to submit and see if everything works out for us or not. Okay, you can see we have cleared all the test cases, 278 out of 278, all passed. And you can also see that it beats 100%. So it's a brilliant and wonderful solution that we just discussed about. Congratulations. Let's analyze the time complexity. Here we are simply moving to all of the cells. You can see here we are just traversing to all of the cells. We have also applied the base conditions so that we don't repeat the same cell again and again. So if there are m rows and n columns, so basically there would be m into n cells. Okay, so we will traverse each of these, hence the time complexity would be m into n only. Let me show you. This would be m into n only. That is the total number of cells. Let's see. Yeah, you can see m into n, where m is the rows, n is the column, so m into n total cells. Okay, talking about the space complexity, we did not use any extra additional space here. We did not use a visited array, although because we are using recursion, it uses tag which has the extra space that it uses. Okay, that would be the only extra space used, but intentionally we did not introduce any extra space complexity here. Okay, so I hope you understood this problem. You can see this was asked in Amazon, so you need to practice all these questions because they may be asked again in any of the interviews. In case you have any doubts, please put that in the comment section. I'll try to help you out. If you want solution of any other particular problem, put that in the comments. Alright then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.